Have you ever stopped to ponder how the simple act of touching a hot stove sends a lightning-fast message to your brain to pull your hand away? This is the magic of nerve impulses, the body's silent messengers. These impulses are responsible for our sensations, movements, and even our thoughts. They are the electrical signals that zip through our nervous system, allowing us to interact with and respond to our environment. The journey of a nerve impulse is a fascinating one, as it travels from the point of stimulus to the brain and back. To understand nerve impulses, we must delve deeper into the neuron, the basic unit of the nervous system. A neuron, or nerve cell, is a fascinating piece of biological machinery, a marvelously complex structure that enables the swift and efficient transmission of nerve impulses across our bodies. Let's start with the dendrites. These are like the antennae of the neuron, receiving signals from other neurons and sending them on to the cell body, or soma. The cell body is the neuron's control center, housing the nucleus and other essential components for the cell's life functions. Once the signal arrives at the cell body, it's converted into an electrical charge and sent down the axon. This long, slender projection acts like a superhighway for nerve impulses, speeding them on their way. Myelin sheaths cover portions of the axon, insulating it and allowing signals to travel even faster. At the end of the axon are the axon terminals, which connect to other neurons at points called synapses. Here's where things get really interesting. When the nerve impulse reaches the end of the axon, it triggers the release of neurotransmitters. These chemical messengers cross the tiny gap, or synaptic cleft, and bind to receptor sites on the next neuron. This action then triggers a new nerve impulse in the receiving neuron, and the signal continues on its journey. So in essence, a nerve impulse is like a game of telephone, with each neuron passing the message along to the next. But instead of whispered words, the message is a pattern of electrical charges and chemical reactions. The entire process is astoundingly fast, with nerve impulses zipping along at speeds of up to 100 meters per second. That's about as fast as a race car at full throttle. The nerve impulse thus moves like a wave, passing from neuron to neuron until it reaches its destination. It's a fascinating journey, one that happens countless times each second in every corner of your body, all without you even being aware of it. The nerve impulse is not just a physical phenomenon, but a chemical one as well. Let's delve into the chemistry behind nerve impulses. It's a fascinating story that begins with ions. These tiny charged particles are the unsung heroes of our nervous system. Among them, sodium and potassium ions play a pivotal role in generating what we call an action potential. Here's how it works. Sodium ions are typically more concentrated outside the neuron, while potassium ions are more concentrated inside. When a nerve impulse is generated, sodium ions rush into the neuron, causing a shift in the electrical charge. This is called depolarization. Shortly after, potassium ions exit the neuron, restoring the original charge, a process known as repolarization. The rapid influx and efflux of these ions create an electrical signal that travels along the neuron. But it doesn't stop there. This electrical signal triggers the release of neurotransmitters, chemical messengers that communicate the impulse to the next neuron. This perfect interplay between ions and neurotransmitters is what helps your brain tell your hand to wave hello, your heart to beat faster when you're excited, or your foot to tap along to your favorite song. And so, the nerve impulse is more than just an electrical signal. It's an electrochemical signal, a delicate dance of ions and neurotransmitters, each playing their part in this intricate symphony of communication. The nerve impulse, therefore, is a delicate balance of chemistry and electricity, working together to transmit information across the nervous system. The speed at which nerve impulses travel is truly astounding. These impulses, the electrical messages that zoom along your nerves, can reach speeds of up to 100 miles an hour. But their velocity isn't uniform. Oh no, it can vary. Factors such as the type of neuron and the nature of the impulse come into play. For example, the faster myelinated neurons race along at top speed, transmitting urgent messages like pain signals. In contrast, the slower unmyelinated neurons take their time, carrying less critical messages. This speed is critical in shaping our reactions and behavior. When you touch something hot, the nerve impulse races from your fingers to your brain, triggering the reflex to pull away. This all happens faster than you can even think about it. So, the next time you pull your hand away from a hot stove, remember the incredible journey that the nerve impulse has taken, all in the blink of an eye.